Okay, good morning. We want to welcome you back. So we're going to jump right on into our sessions. But at this time, I'm going to bring up Chris Pruitt because he's going to be kind of the MC for the rest of the day, introducing all of our session speakers. So Chris, if you could come forward at this time.
How you doing? I'm Chris Pruitt from the Office of IT Security. Today we have Susie Adams from Microsoft here, and she's going to be doing a session titled Cloud, Mobile, and Internet of Things.
Thanks.
Just give her a hand.
So I'm hoping they don't yell at me if I have to stay between these lines. I like to walk around a lot. And at least behind the podium, I tend to look like this. So Susie Adams, I'm the CTO of Microsoft Federal, so I go across to all of Federal. I've been with Microsoft about 18 years, but before that I was a developer, so I grew up as a developer. And as developers, any developers in the room? We hate security, right? Because it stops you from doing what you want to do, typically, and it really can hinder the application's performance from an end user perspective, right? And so that's always been one of the trade-offs. And as an employee of Microsoft, obviously we are a software company, and so that has been one of the things that we have struggled with over the years. How do you build secure software? Right, make sure it can be deployed securely, but not really inhibit the end user's ability to use that software. All right, and so I'm going to talk a little bit about kind of what's changed now, today. Why is cybersecurity at the top of everybody's list of things they need to worry about today? How is it going to change, or does it change, right, as we move into the cloud era? And then talk about, kind of some of the challenges with just building secure software. And we'll see if it's going to go here. Oh, there you go. Okay. So if we look at just where we're at today, I feel like I've been talking about the pace of change is so overwhelming, right, for the last 10 to 12 years. But if you look at it today, and you just look at where we've come from in the last couple of years, this is not, 10 years ago. This is just the last 2 or 3 years ago. Right? Just look at the price of some of this technology. 3D printers. How many people remember when 3D printers were like some fad? Or something that you could only get, it was like $1,000, nobody was ever gonna have them. Now your kid gets one for Christmas, right? And you're seeing these little plastic things all over the house. That's remarkable. I mean, how fast did that happen? That's ridiculous, right? Think about smartwatches, the Internet of Things. How many people have a smartwatch on? Right? And you probably this is probably not your first smartwatch, right? It's your second or third, right? I'm on my fourth, and apologize, I have bad allergies. And so if we think about the pace of change, and now we add cloud to that, right, it's pretty daunting. And what's really changed? Right? If we look at the industrial revolutions that have happened over the year, and if I were to have a slide that showed the industrial revolution starting, 100 years ago, right, you could think about things like the steam engine, right? And then when we started to get computers, which was a mainframe computer, I'll date myself, I went to George Mason, and I actually did use punch cards, right? And almost did not go into computer science because of it. My first class was punch cards doing Fortran. Right? Then we went to the personal computing era, right? And we started to see the IBM PCs and the Commodore 64s. And then we entered the web world, right? And we had multi-tier applications, right? And SOA-based architectures, service-oriented architectures. And while we tried to secure all those, it was pretty consistent. We knew what to do. We knew where the perimeter was. We knew we had a network we had to protect. If you were going to connect to the web, right, and something bad happened, you just pulled the plug and turned off internet connectivity to your environment, right, to your enterprise. Right? And then you assign a team of people to try to figure out what happened. You didn't let people read their email at home or log on from home. Then we got VPN. It wasn't long ago you could only look at your email on a BlackBerry, right, in the federal government. Right? So now, what's the world look like that we live in? All right, so this is kind of the world as we used to know it. Here's our data center, here's our perimeter, we had some mobile devices, maybe some policy, maybe not a modern day mobile device management software product, but something that would manage your mobile devices and wipe them if you lost them, right? And sets a little bit of policy on them, right? But where we're going today Is it not working? It's going to build. So go ahead and click. All right, click again. Keep going, just build it out. Where we're going today, right, is you'll see SaaS adoption, cloud, Office 365, Google, right, Salesforce. People are adopting clouds, mobile device experiences. You're using any device, right? It's device du jour, whether it's an iPad or an Android or one of the new Microsoft devices that are out there. Click again. Internet of Things with the handheld devices and the mobile watches. Go ahead. Right. So this is what the modern perimeter of an enterprise looks like today. It's no longer that physical perimeter with the guards and gates and guns. You can almost say that it's perimeterless. Right? The edge has now become the device. And this is difficult for people to grasp. When people when security professionals, right, see this picture, they're like, oh my God, how am I going to manage this? This doesn't make any sense to me, right? I manage my environment, what's outside of my environment, right, I don't have to worry about kind of mentality. And even our policies and regulations in the government today kind of mirror the old way of looking at things. Trusted internet connection, right, is a great example of that. That was written in 2007. And that's 10 years plus old, right, for looking at things. And that's when all we did was browse for websites. We didn't really use anything outside of our data center for the most part for mission critical applications. And so how do we protect this, and what needs to change when we think about cybersecurity moving forward? Click. All right, well, first of all, we used to think about security or productivity. You locked everything down, you made people come to the office for the most sensitive workloads, they had to log onto a secure device, right, or they had to VPN in and have special access privileges to get this, or productivity where they could work from anywhere on any device, or maybe telework. Right? We didn't think you could have both. Click. Where we're trying to go is security and productivity. How can we take advantage of this new innovative technology in this perimeterless world, right, where we feel comfortable that we are securing the data regardless of where it lives? And click. To do this, right, we really have to take a different mindset. So this isn't really new. Protect, detect, respond. Everybody's heard that, right? That's kind of the mantra for most cybersecurity professionals. But if you look at where we've spent most of our time, it's protect and respond. We protect everything, the edge. We say nobody's ever going to get in. Right? We're confident. We got best practices in place. We have good hygiene practices in place. We're patching. We know what's going on in our environment. We should be good. And then, heaven behold, we find out that we've been breached, and then we find out that that breach occurred 221 days ago. Right? And then we try to respond to it. And it's somewhat nightmarish because you really don't know where that attacker's been inside your environment. You don't know how many devices it's touched. You don't know what data's actually been stolen or why they got in. Right? And we spend a lot of time then on that response. Where we really need to invest moving forward is in the detection phase. We want to know within a matter of minutes, not weeks, months, right, that a cyber event is happening. We want to be able to identify what that cyber event is and then have policies kick in, have automation that automatically starts to work behind the scenes. So we're not just depending on a cybersecurity professional looking at a screen or running a report on a daily basis to try to look for anomalies. Right? We want automated detections to start happening. Right? And if we think about detections, what are you going to look for? The things we look for today, there's a laundry list of them, but most cybersecurity professionals get very versed in these quickly, and they're looking for the standard types of intrusions. The attacks today are much more sophisticated. They're doing phishing attacks, but those phishing attacks are super targeted to a point where you can't even detect that it is a phishing attack in a lot of instances. Right? And people are clicking on those. So what we need to do, and this is really hard for cybersecurity professionals, is assume breach. Click. And when we assume breach, what that means is that you're going to have You're going to have detection tools in place, right? And people that their only job is to look for the bad actors and assume they're in there 24/7, 365 days a year. Hunters. Right? And I'll explain how Microsoft does this today and kind of how we're going to help our customers moving forward. As we're trying, you might have recently seen that we invested about $10 billion in the cybersecurity software arena. From building tool capabilities into our products that we're offering, whether they be cloud-based or on-premise, but also in acquisitions of software companies, right? Cybersecurity software companies that we're including into our products. And the reason we're doing that is we want to make it simpler for cybersecurity professionals to manage this very distributed world that we're going to live in. Right? And there are some key points of how you can do this. Next slide. All right, so if we have to do if we need to manage this perimeterless world, does the security paradigm change? And we think it does. We think if you're going to protect data, regardless where it lives, you need to be able to lock that data down and give an end user the key through identity to be able to look at that data. And you need to be able to monitor that access real time. All right, so identity really becomes the new firewall. The second is the devices are the perimeter. It's no longer your data center. Any device that any end user is using that's touching your network is the perimeter. You need to know what is that device, where is that device, who is using that device, and what data is that device trying to access, and is that device patched and up to date, and does the operating system have any known vulnerabilities? Then based on that, assign policy to what that particular device to end user combination has access to. All right, and change those policies based on the security posture of all of those attributes and what you know. All right, now this sounds like a daunting task. The technology already exists to do this today. It's already out there. People are already doing it in the commercial sector, and in fact, that's how we manage our environment. We have people on a global basis that use any device they want. There are no rules. We can use whatever device we want. We can join it to the network. The only thing that happens to you is it becomes managed. Then based on the security posture of that device, if you choose not to update that iOS device and we know there's a known vulnerability, guess what? You don't get access to anything. They stop mail from coming to you. You get a nice little email that says that device is no longer allowed to join the network, and so sorry, but update or you can't use it. Right? And we do this all by policy. And so these are the types of technologies that people need to employ. And again, assume breach. So next slide. The other big thing that we add to the equation is big data analytics and machine learning. So we're so used to monitoring our physical perimeter using just NetFlow data, right, and basic log files. And we think if we can look at that NetFlow data, we'll see a bad actor, right, doing something to attack one of the systems. In reality, you need to look at much more than just the NetFlow data. Right? So trusted internet connection in Einstein are great tools, but they're just that, one tool, to look at just NetFlow data. What we really need to look at is signal from all the devices and from all the applications running in that environment and all the physical devices anywhere in that network, anything that's touching your network. And we need to look at all that sensor information, put it in a big data store, whether it's a data lake or a Hadoop database, and then run machine learning algorithms on there to start to see anomalies that humans can't see or can't see, unless they were to look at it for, longer than their lifetime. And when you start to see these anomalies and you see them across the board, and while it's valuable to just look at the sensor information from maybe a single large organization like yourselves, it becomes even more valuable if you have a data store that's actually looking at anomalies on a global basis. So what we've done is built something we call the Intelligent Security Graph. And it's just that. We take anonymized sensor information from people touching our networks, and we start to see bad things happening. We know when a virus is happening. We can actually track it globally. You can actually, inside of Azure Security Center, which we just announced for government, you can actually drill down in. It'll set an alert and says, we see that you're getting this virus on one of the devices in your virtual environment, and it will actually show you where that started and where that attack is happening on a global basis, and help you, right, then act or respond to that event. Right? And these things are real time. So people are being notified, policies are being applied, that device is being removed from the network. Right? All before a human has to act, right? Based on whatever that event is. Right? So what we've done moving forward is we're using all this data in our cybersecurity tools that we have to kind of power that by the cloud. This is all cloud. And what's allowing this to happen, and I think that's the big difference, and why we're really in, if you remember the first slide, the next industrial revolution. Right? We're moving to a world that is powered by hyperscale compute. That hyperscale compute was only available at the university levels in very large organizations, Department of Defense, and very, very, very expensive. Right? Now we have this hyperscale cloud compute capability it's commodity, basic commodity-based prices. So now people can take advantage, right, of all this data and all this information to actually secure their environments and to do some really cool things. Think about it from analyzing even housing statistics globally to start to see anomalies, right, of things that are happening in the world, or healthcare. I think healthcare is probably one of the biggest areas that's going to see just a phenomenal change. I mean, think of all the data. If you could keep all the sensor data of a cancer patient and then start to see anomalies based on the treatments they're getting, right? They already do this with childhood leukemia to some degree, but it's all paper-based, or a lot of it's paper-based. The cure rate would go up dramatically, because right now it's only a single practice or a single group, right, or a single study that's really sharing that information. Imagine being able to apply these advanced algorithms to these very, very large data stores, be able to see this, not running, a MATLAB or a statistical app, but using hyperscale compute. Hundreds of millions of servers that are out there that you can use, right, just to run a single query. Next slide. All right, so it really is a mind shift. We were kind of in the world from a cybersecurity perspective of, it's never going to fail, we're never going to be breached, right? Now we have to design to recover quickly, to detect and recover very quickly. Next. Right? We used to say, prevent every possible attack. Now we're like, it's kind of a compromise. We're going to protect and detect, and we know some bad actors are going to get in, and then we're going to respond. So you don't forget about everything you've already learned about cybersecurity. You still have to do all those best practices. What you need to do is add additional tools to your toolbox to help you manage this very virtual, perimeterless world that we're all going to live in. Next slide. So when we think about reimagining security, there's a couple of imperatives. You have to have visibility and control. You have to monitor. You have to have those detection capabilities. If you don't, it's going to be very difficult to manage this environment. Almost impossible, which is why people are so afraid to do it, frankly. I mean, we used to talk about just moving to the cloud as a scary thing. Now, everybody's scared to death of what might be. How many people have walked into a building, a federal building, and had to take off every device they have? I have. Pull everything out of your bag, every cord, every wire. They want to inspect it, right? Because they're scared to death because they don't understand how these things work or how to protect against them. Next. Right? We want to spend time on detection. Next. Right? And we have to find and protect the data. Right? So it's really identity, detection, right? And then we need to classify our data. How are you going to protect data? Right now, it's kind of a one-size-shoe-fits-all for data for the most part. All data gets the same level of protection. Right? In our world at Microsoft right now, what we do is we have 3 levels: low, moderate, and high business impact. And then based on that, there are policies that get into place. So if I'm trying to look at high business impact data, maybe it's source code, and I'm on my iOS device, and it's 2 OS versions back, and I try to log onto the network and get there, and let's say I have multi-factor auth enabled, but I'm not patched, it's not going to let me get there. It's going to tell me, I'm sorry, access is denied, you must patch your system first. Or if I try to do multi-factor auth, right, it won't do that. So it's really a combination. I should probably add a third thing here, or a fourth thing. You have to have multi-factor authentication, right? Multi-factor authentication is key to identity as the new firewall. You need to spend a lot of time and energy on detection and make sure you add those tools to your toolbox. You need to be able to classify your data, right, and know what the sensitivity of that data is, and auto-classify. Don't just leave this up to your end users. Right? That will never happen, no matter how much training you do. Right? That's one of those trade-offs. Is it going to be usable, or is it going to be secure? We want to assign policy and have it automatically happen, so it's secure and usable. Right? So it should automatically classify documents if they aren't classified themselves by the end users. Right? Next slide. So if we look at our security investments here, right, there's 4 major areas: threat protection, information protection, security management, and identity and access management. Right? And looking at all those, right, these are some of the things that we have today that are available, and some of the things that you already own. And I don't know which of these you already own, but I do know you own some of them. So inside of Office 365, for example, we have something called advanced threat analytics. Advanced threat protection. So what we want to do in Office 365 is, if an end user receives an email and it has a link in it, don't depend on the end user's training about what a phishing attack looks like. When the user clicks on it, send that link to a detonation chamber in the cloud. If it has a virus, report that, right? Make note of that, track that inside the Office 365 Security Center so that your security professionals can look at it, notify the user that that email has been infected with a virus. Now, both the security professionals and the end user understand nothing bad has happened. And that's just something you turn on. End users don't even know it's happening. Right? We've been running it forever, and we never knew. You don't see anything. It clicks, and if it's good, it comes back to you. First time I realized that we had it turned on internally is when I got a bad link. Right? And I popped it up. You want to be able to do information protection, and not just rights management. Right? How many people have ever right-clicked and rights protected an email or used SMIME to protect an email? Right? That's great. You're encrypting the email. But really what you want to be able to do is add conditional access policies to data. And so we used to have something called rights management services. We acquired a company called Secure Islands. Secure Islands is now what we call Azure Information Protection. It's a combination of rights management services and Secure Islands. And this is what protects your data on any device on the edge. You assign those protections to that data, and it travels with that data wherever it lives. As a security administrator, you then can run reports to see who has tried to access that data and what that end user did with that document. Then, using machine learning and advanced analytics, you could start to see trends from that end user to see, is that user actually looking at information they should be looking at to perform their daily job and duties? If not, you probably have an issue. If they're just trolling the internal sites looking for information and trying to click and access things, right? You're going to see that, and it's going to report by policy, hey, Susie's doing something really crazy over here. I'm not sure what's motivating her to do this, but you might want to ask why she's trying to access all these documents, right, across the board. And then we have something called Windows 10 Advanced Threat Protection. And this is where I talked about the intelligent security graph, where we take all the anomalized sensor information. We actually have hunters, teams of people that's all they do is look at that information, right, and try to make heads or tails of that data. And now we extend this service to our customers that are running Windows 10, so they can actually send us their sensor information, right? And what we get, it's all anonymized, and our hunters will look at that specifically and let you know if something bad is happening. As well as there's a set of tools that you can use that are going to apply and kind of merge those two data sets. Right, we just purchased a company, which I'll show in a second on a slide, that's going to extend that capability even further and add some advanced detections in some other devices. Next slide. So when we talk about protect against advanced threats, right, you'll be able to see 0 day. It's actually 0 day protection from links, right, from phishing attacks. The suspicious behavior, which I talked about in the security management, advanced security management. Next slide. Threat intelligence. All right, you can rearrange this dashboard. This is Office 365 Security and Compliance. There's an Azure Security and Compliance Center. The Azure Security and Compliance Center can integrate with this and let you manage not just your cloud, but see anomalies from other clouds, and you can actually point it to your systems on-prem. In fact, SBA just did this. Right? Guy Cavella over at SBA, who is the CTO under Maria, he tells a funny story about how they turned that on, and they automatically started seeing things that they had never seen before. Like, for example, very easy to guess administrator passwords, like admin, right? That they never could detect before. And so they just, by turning on Azure Security Center, having a direct connection through ExpressRoute to us, right, to be able to monitor those, they now have a single dashboard where they're looking at their whole environment, that whole perimeterless world. Then you have to add mobile device management software on top of that, right? Traditional, but also you need to extend that to the data and information protection. And you can then see that entire world that I had that first picture up, that shows all the different things, the endpoint protection, the data protection, the identity protection, right, your physical environment protection, as well as seeing anomalies in traffic in the cloud. It's all that signal that you have to manage and be able to look at and make heads or tails out of, right, in a single pane of glass. So that whole concept of I need a single pane of glass from a SIM tool perspective, SIM tools are great, you still need them, but you're going to need to look at a much broader array of sensor information than just log files. Right? It's going to be much more complicated than that moving forward, and that's why automation and tools, right, and hyperscale cloud compute is really going to become a huge friend and game changer for cybersecurity professionals. Next slide. Again, this is again, I think it's Azure Security Center. Oh, this is Operations Management Suite. So we've always had the System Center suite of tools. Right? And so the System Center suite of tools has a companion in the cloud called OMS, or Operations Management Suite. And it can actually ingest, right, that data from on-prem as well and integrate with Azure Security Center. So there are a couple of different tools in our toolbox that you can easily and quickly use to help you manage that environment, from Security Center on-prem to OMS, Operations Management Suite in the cloud. And then if you're using Office 365 or Azure, you can use the Office 365 Security Center and the Azure Security Center. The really nice thing about the cloud, which is what is kind of the game changer, is that it's all about software-defined everything and APIs. Right? There's an API layer at every step, up and down the stack, which doesn't typically exist, right, in traditional computing. And so if that API layer exists, and you can extract sensor information, whether it's who logged on, what time they logged on, what did they do, right, and then start to record that information, right, into a big data store. Now this is a lot of data. We didn't do this before because it was a lot of data. We had nowhere to put that data. And it was expensive to house that data. So we thought just looking at log file or NetFlow data was good enough, because that was a lot of data in itself. Now that we have big data and hyperscale compute, we can look at all of it, right? Which is really what's going to give us the visibility that we need to be able to manage this world. Next slide. And then from a log analytics perspective, like I said earlier, it's not that we're going to stop doing what we already know how to do. Right? We still need to do that. You still need to look at your log files. But we need better analytical capabilities on top of those. And so we have, for example, inside of Azure, the ability to do advanced log analytics using Power BI, right? And be able to slice and dice this without having to call somebody to teach you how to write a report in Excel or do a funny graph. You'll just be able to drag and drop and do these things as a cybersecurity professional without having to write any code. Next. And then see the trends and analysis. We have a threat explorer and threat reports, malware reports. All these things come right up in the dashboard. You can literally click, and based on what you're monitoring and what endpoints you've pointed the solution to and what it's reporting on, you'll be able to start to just see these things real time. And they are real time. I mean, we use these tools internally at Microsoft, and if you get anything on your device, but almost before it comes up, you've got an email, or somebody is sending you a text message saying, hey, your device is protected, or it's already kicked you off the network. And you're like, why aren't I on the wireless network anymore? I don't understand what happened. And they found something on your device, and they're already sending something to it to try to patch it, right, or fix that problem before I ever have to call the help desk. Right? Which is really, I mean, it sounds, kind of sci-fi, but it's really not. And it doesn't even feel like Big Brother. It just makes the end user experience so much more enjoyable, right, when that stuff is just taken care of. Next. And then the policy part of this. I think the policy part is probably one of the most important things that any enterprise can do, because every enterprise, the sensitivity of the data is different, and the policies are going to change based on the sensitivity of that data, and there's going to be trade-offs on security risk versus the ability for somebody to do their job based on the sensitivity of it. And so policies are really key here. And so you could set up policies that say, if I see that this valid credential has logged in to the system in 3 places globally in a matter of minutes or hours or whatever your policy is, and there's physically no way for that to happen, I'm going to prompt them to call the help desk. I'm going to lock them out. I'm going to require them to use their PIV card to access. If you have other multi-factor, we do multi-factor. We have a smart card. We can use the smart card, or we do phone-based multi-factor authentication with something we procured a company called Phone Factor, and through an app. So we can actually do biometric as well now. So when I log onto my phone, I have an iPhone, and I want to go and do something, it will prompt me. If I go to a web page that's got sensitive data, it will literally prompt me and say, you have to go to Authenticator, and it's going to ask for my thumbprint that is tied to my phone, which is my second factor of my device, and that device is managed by Microsoft, right, and being tracked. Next page. So you might have seen in the press we acquired a company called HexaTight. So HexaTight is that company that's looking at all those different, it's kind of building on our Windows 10 Advanced Threat Protection. We're really excited about this. The technology will just be merged. I don't think we've decided what we're going to call it then when it gets merged. But again, it's just our kind of investment in cybersecurity. And our goal is not to become the cybersecurity company. That is not our goal at all. We want to democratize the way cybersecurity professionals can analyze the threats that they're seeing and the data and the sensor information they're getting. Right? And then we want to work with all the other cybersecurity vendors that are out there today to ingest all these tools. Because there are best-of-breed tools we're not in that market. A lot of the investments we've made is to manage that very perimeterless world and the tools that we have and be able to make heads or tails, right, and visualize that information so you can quickly act on it to reduce the time the attacker's in your environment, and then quickly tune your sensors to be able to pick up that attack so that particular attack can't happen again. Right? That's really the goal of what we're trying to do with our investments in cybersecurity. Right? Because if you're in the cloud and you're on a mobile device and you're trying to get your job done, right, you need to be able to feel that you're secure. And the only way to do this is to have an investment, right, and use the power of hyperscale compute to allow you to see that. Next slide. So if you go and talk to Brett Arsenal, who's our CISO today, he's going to tell you that we, as a company, have 4 security imperatives. Multi-factor auth, conditional access, only healthy devices get access, consistent logging and telemetry, this is all the sensor information that I was talking about, not just from physical devices and just not at the network layer, but at the application layer as well. Right? And then we have to protect that data regardless of where it lives. And if we could do all 4 of those, right, we can reduce the threat surface, the attack surface significantly. Right? And this is over historical data of people trying to attack Microsoft. And so when you look at how our IT department is looking at it, everything goes through that litmus test. It has to be doing one of those 4 things. Right? And that's where most of our major investments go, is in these. And so we actually have a it's actually somewhat 3-dimensional chart of the conditional policies. If you're on this version of iOS and you're running this app, there's some apps we're not allowed to. If we can install them and use them, but you can't access them or use them on the corporate network or use them to ingest any corporate data. Right? When that data is downloaded, and if I were to try to send it, let's say Dropbox was deemed an insecure environment, we would not be able to drop any Microsoft documents, whether they're low, moderate, or high impact, onto Dropbox. It would stop us at the app layer. Now, one other thing I wanted to kind of call out here is we also purchased a company called Adalom. Has anybody heard of Adalom? No? Okay, so Adalom is now called Cloud App Security. So, the whole, I call it cloud creep. Right? How many of you have seen where end users are just using the cloud app du jour that they want to use out there? They go out, they start using it, they're sharing documents, right? It's never ending. There's a new cloud app out there all the time. We find it's kind of rampant how many people will stand up little team sites to collaborate, or maybe collaborate with people in other federal agencies, and they're not really sanctioned apps, right? And data's kind of flowing freely through this. And so Cloud App Security will show you that. So you'll see what end users are using what apps. And so we're actually tracking that information on your network. So if they go out and they use, Google something or whatever app that you deem shouldn't be used on agency data, you'll know that they're doing that, and you'll be able to shut it down. This is huge, and when I talk to people like NASA JPL and some of the more scientific groups that everybody is an engineer and everybody wants to do whatever they want to do, those types of tools, for the back office, the folks that are running their own shadow IT, and get the little cloud creep now going into shadow IT, that you'll be able to manage this, right? And be able to manage it effectively. And then if you are using those third parties, get sensor information from them. That's what you need. You need data from them too, so you can manage that environment. Otherwise, you won't be able to manage it. And so a good cloud vendor will allow you, through the APIs that they've exposed, to be able to gather whatever information you need to be able to throw that into your tools to be able to better manage that virtual environment. Next slide. And with that, that's all I have. Any questions? No questions? Are you guys using any tools to help you manage cloud today? No? Okay, everybody's quiet. I don't know off the top of my head either, but I can work with Denise. I'm not sure if Denise is in the room, but I can work with Denise to find out, because these tools are just in the box. I think you probably purchased E3. Some of the tools aren't in there, but they are available. You just turn them on, depending on which tools you want to use. Like Advanced Threat Protection, I think is a level up, on the price list, or you can purchase it separately. But these are all things you can just turn on. Right, to be able to help you to manage that environment, and integrate it with your SIM tool too. We work with all the SIM tools. You can take those log files, and I'm not sure what you guys are using here, but you can take that information and put it in your SIM tool too. We work really well with Splunk. For example, we have people hosting Splunk in our Azure cloud and taking instead of shipping it back down over the network connections, just using our internal backbone to be able to send that data to Splunk, running in a virtual server or series of virtual servers inside Azure, Microsoft Azure, our cloud. So we did that with EPA, for example, with Office 365. We started pulling data in there for the tick overlay project. Yes. Oh, I should have repeated the question too, sorry.
And good morning.
Morning.
Question for you about bring your own device. Like, I know that you have a product for Windows Defender to actually be able to look at the device first and then like see whether or not there's a threat potentially coming from there. Like if you have BYOD, that might be like a bit of a conflict with the users being a little nervous about having something actually go on their device and look around and see, well, look, what are you doing? You know what I mean? Just out of curiosity, like, is there like something that you would recommend for that?
So there are agentless technologies that kind of allow you to do this, right? Our Intune product is somewhat agentless. But I will say to you that while it seems weird, the productivity gains you get to be able to do this, there are also, when Intune manages, it actually has a separate area for your enterprise data versus your personal data, right? And you can put it in different containers. It really depends on the device, though, right? How this works. So I'd love to talk to take that offline with you. I know I'm getting the 5-minute warning, but that's a really good question. And I think it was a cultural problem inside of Microsoft too. Everybody's like, I'm not letting Microsoft manage my device. What happens if I get fired? Do they look at that information, or they use it against me? Kind of thing. Everybody has their mind like in that. But I will tell you now that any device I buy, I'm like, I don't care. I mean, what are they going to look at? I'm just using it for work, or I'm using it to get access to things when I'm teleworking, which I do all the time. I don't have an office. So I'm everywhere, and I can be anywhere. It doesn't really matter, and use any device. So there are pros and cons. I mean, that's the bottom line. So, or you can just do browser-based access.
Yeah, that's true.
Yeah.
One quick comment. So one quick comment. We're about to implement something called MAM, which is less intrusive than the overall BYOD implementation, which should be placed in the legal aspect of our HUD organization, which will weigh in and say, well, this is less intrusive, this could be more intrusive.
BAM? B-A-M?
No, MAM, M-A-M, Mobile Application
Access.
Management,
Oh,
which
okay. Yeah,
is
yeah.
only concerned with the corporate data versus the person's private data.
Yeah, no, absolutely. You can manage things at the application layer completely. You can do virtualization. There's a whole host of things that you can do to allow people to work remotely and still give them access to the data in more of a container-based fashion. Yeah.
Hey, good morning. My name is Joachim Pope from the Office of Public Housing Investments. I work in our Connect Home program,
Oh, cool.
HUD's digital inclusion program for low-income HUD-assisted households. Cybersecurity is a topic we've been discussing at length, and I'm curious. We've spoken with groups like Cisco and the Cisco Academy about the 500,000 jobs a year that aren't filled in the tech sector. A lot of them are presently about filling cybersecurity roles. It's trending as one of the fastest growing employment markets from what we've heard.
Yep.
I'm wondering, is Microsoft doing anything to try to help create job opportunities that might be available for HUD households to learn how to get into that sector because it's such a fast-growing market?
That's a great question. I don't know any large formal programs. I know we support, from an education perspective, a lot of smaller programs to help cybersecurity professionals, and we promote like STEM, all kinds of STEM opportunities across the board with cybersecurity professionals. We work with Karen Evans a lot and her group that sponsors the, I forget, the cybersecurity games, right? Attack games that she does with college kids to be able to do that. It just like captures the flag or something they play, but from a cybersecurity perspective. We do a lot of that. I'd have to get back to you. I can reach out to my education counterpart. I'm sure we are. I just don't know about it. But that's a great point. I mean, I have a nephew who's in his fourth, and he'll be going 5 years, to getting a computer engineering degree. And I'm like, you need to go into cyber. You'll be able to name your number by getting a cybersecurity degree right now. There isn't enough people, and there won't be for a very long time. Right? So if you have kids going to college, tell them to do this, because that's, I think a lot of that promotion has to happen. But from a training perspective, I mean, we have the Microsoft training series that there is a cybersecurity track in that. And then when you go and look at all of our classes just in general, there's a huge focus on cybersecurity moving forward. But I don't know if there's a particular program. But if you can, if you want to see me after and give me your card, I will follow up with you on that, because that's a great question. I just don't know the answer.
Thanks.
So I think that's all the time I had. Thank you very much for having me. If you have any questions, please shoot them to me, susiea@microsoft.com. That's SUSIEA@microsoft.com. Thanks, and have a great day.
All right, we want to thank Susie. And we'll have our next speaker at 11:15. He's from the Department of Homeland Security. All right.